Hello people, welcome back to the channel. Hope you're doing well. Today we'll solve the problem. Add edges to make degrees of all nodes even. What does this question state? There is an undirected graph given to us which consists of n nodes numbered from 1 to n, and you are given with the integer n and an 2D array edges. Uh, for each edge in edges, there are two numbers a and b, which means there exists an edge between a and b. uh, the given graph is an undirected graph, so there is an edge between B and A also. So, what is the question asking us? It is saying that there are multiple edges between nodes, and we have to make sure that for every node, there is the number of edges which are connecting to the node are even. For example, in the given example 1, here the fourth node has three edges. The degree of 4 is 3. That means there are three edges connecting to it. But we must make sure that every node in the graph is even. So in the same way, the number of nodes for 5 are 1, which is odd. So what can we actually do here? We can provide an edge between 4 and 5 so that the number of edges connecting to 4 will become 4 and the number of edges connecting to 5 will become 2, so that every node has even number of edges. That means every node has even degree. But the condition here is we can only add two edges. That means at most we can add two edges in the complete given graph. So we can add either one edge or two edges. So in this given graph, we are having two nodes of odd degree. This 4 is having 3. This 4 is having the degree of 3 and this 5 is having a degree of 1. So actually we can make an edge between 4 and 5 such that the degree of 4 becomes 4 and the degree of 5 becomes 2. Both of them turned to even degree and the graph is having all the nodes with even degree. So what do you understand by this? We were having two nodes with odd degree and we have used one edge to make to convert them into the even degree. So how many number of odd degree nodes can we have at most? The answer can be 4, right? Because if we are having four odd degree nodes, then we can use two edges to convert the four nodes into even degree. How so? I'll explain. If there are four nodes A, B, C, D, all the four are having odd degree. So what can you actually do here? You can actually place edges between A, B and C, D. This is the first case. Or you can place an edge between AC and BD. Or you can place edge between AD and BC. These are the only three possible ways so that you can distribute the two edges to the four nodes, right? So let us suppose these are having the edges like this and you want to place edges. So we'll try the first combination. We want to uh, place the edges between A and B and C and D. You can place it right away and the graph converts into the even degree. So we can follow the first pattern and distribute the edges in between AB and CD. Now we'll take another graph A, B, C, D. In this case also we are having four odd degree edges and we want to place two edges such that this graph converts into even degree. So we'll try the first combination. We'll try to place an edge between A and B and C and D. First we try to place an edge between A and B. This cannot be happening because there is already an edge between A and B. So first case cannot be happening. We'll try the second case. We'll try to put an edge between A and C. There is also again an edge between A and C. And again the third case is also not possible because there is an edge between A and D. So we at any cost, no matter what, how you try, this graph cannot be converted into the even degree nodes. So what do you understand? In case one, we can have two edges so that we can convert the graph into even degree edges, even degree nodes. I mean, sorry, these are nodes. We can have two nodes with odd degree, or else Second case is we can have four nodes with odd degree. We can have only these two cases. If if we have more than four nodes, we cannot convert, because to convert the more than four nodes, we should require more than two edges to convert them into the even degree. So more than four nodes cannot be happening. So till now, what did we learn? If the graph is having two odd degree nodes, we can directly connect them. Or else, if the graph is having four odd degree nodes, we can use these three scenarios and try placing those edges. And if we succeed, the graph can be converted, or else it is not. So there is an extra edge case in two degree nodes, two odd degree nodes. What is that? If we are having a graph like this, in the question, we can clearly see that the graph is a disconnected graph. So it can be having multiple components. So if this is a component and this is a component, and here we are having two odd degree nodes, and we can actually connect the graph in such a way that we can place edges between these two nodes such that the every node is having an even degree now. So this is an additional edge case we need to handle. So we'll see the code now. So first of all, we are creating an adjacency list here. We are creating the graph here. Make sure you give a set here, because while accessing the elements in the set, it is easier to pick. That means the time complexity for accessing an element in a set is order of one. If you declare a list here, there will be a TLE issue. So make sure you declare a set here. So after creating an adjacency list, you'll store all the nodes which are having odd degrees into this odds array. And then if there are no odds, that means the graph is already in the required manner. Every node is having even degree and you can directly return true. And if it is having more than four odds, that means we cannot, no matter how we try, we cannot convert the graph. So we could return. And if the number of nodes in odds are four, that means we can actually put the two edges between the four nodes, between only those four nodes. And I've already explained the three scenarios which we can use to place the edges between the four nodes. These are the three scenarios. You can only place an edge between A and B if adjacency of A is not having B. That means there is not an edge between A and B already. And you will try to see if you can actually place the edges in any of these three patterns. And if you are able to place such way, you can return true, or else you can return false. If there are only two edges, this is for the two nodes. If there are only two nodes in the odds array, then you will take the two nodes and see if you could place an edge between those two nodes. You can place the edge between those two nodes if there is not an edge already between those two nodes. And if there is an edge between the two nodes, you can check for a node such that these two nodes are A and B. You can actually create a graph only when there is another node C such that neither B is connected to it or A is connected to it. Then you can actually create the two edges between B and C and A and C, and you can return true there. This is the extra edge case that I have explained in the earlier part of the video. Okay, thank you guys. If you like the content, please like the video and subscribe to the channel. Bye.